Good morning, I'm Stephen Cook with Cook Saw Manufacturing, and a beautiful April day in 2017. We're wanting to just do an updated video of our MP32 sawmill that we've been building for many years now. We've been building sawmills since 1994 and other equipment even prior to that. We've been in the sawmill. I'll give you a little bit of history. We've been in the sawmill industry for over 45 years. My dad was a minister here in Wicksburg, the little community where we live, a little rural community in Alabama. And we grew up, and he was a preacher and a little country church. And he decided that as we were young, three of us boys growing up, that he needed to provide a little bit more, and he hated to ask the church for more money. So we asked if he could start a little side business. And his dad was in the saw blade repair business, using the old Foley bell saw, if you've ever seen them from long ago, and they may still even be out there. And he would go around to cabinet shops and pick up saw blades. Well, my dad started doing that as well in our area. And it wasn't too long that he found that sawmills needed work on their blades, from strobe saw blades in gang rigs to the big head saw blades, 42, 50, 60-inch blades, even some 6-foot blades for cutoff saws in some of the bigger mills. And he became a hammer man, we call it, where he'd hammer on saw blades and put tension into the blade so that they run. When it's interesting, when they run a circle blade of that kind of size, that diameter, it has to, when it slings, there's centrifugal forces, and it has to have the correct tension, and that can be hammered in, it can be rolled in. And so he learned to do that a long time ago, and that was where we got into the sawmill industry. I was probably around 10 years old when he started doing that. I might have been a little younger, but 10 years old I started working, we called it, probably just coming around and learning a few things. But we would sharpen a few blades. I would, and I'm the youngest of three brothers. And but we began our education really in the sawmill industry way back in our youth, and we have continued that, and so it was over 45 years now that we've been, our family has been in the sawmill industry, dealing with saw blades particularly. And then in the early 90s we began more and more getting into manufacturing of sharpening equipment for setting and sharpening, and we've been innovators in some of those things. And then we also, shortly after that, in the early to mid 90s, we began building portable band sawmills. We actually built a hydraulic mill, was the first mill that we built. And then the mill that I'll show you this morning is our MP32, which is a manual portable mill. And we started building this as another market. It is a hobbyist mill is kind of how we market this, but it actually will compete with some of the other mills that are out there that are much higher priced. It's a big heavy-duty built mill, and it is a mill that we have been building again for years. We're confident in it. There's very few problems with this type mill, and it just is very consistent. It is a machine that if you buy it and use it on your farm to build, maybe you want to build a barn or cabinets or horse stables, build a house with it, just numerous things you can do with this mill, and then you can pass it on to your children. This mill will last a lifetime and more, and just a good solid machine, and we're very proud of it. We've added features over the years as we've gone along, and I want to show you these features, and then I'll saw a little bit with it and show you how it works. But I'll begin by opening the doors here. This is something we changed a few years ago. We listen to our customers, and we want to make changes that are beneficial. And so we added a metal door here. Looks real nice. We had a wood door, and it had some functions we liked about it, but having a good solid door there is what our customers seem to want. And so we went to that door several years ago, actually. I began by talking about our metal bandsaw wheels. These are 19-inch wheels. This is a standard in this size machine in the industry. And something special that we do about these with these bandsaw wheels is it became apparent to us 8 or 10 years ago, probably 10 or 12 years ago, a good while back, about vibrations that happen to the bandsaw blade. And we had used the urethane wheels and turned them. Those do pretty good. We've used belted wheels. You know, you try to balance what's the most inexpensive versus how much things cost you. And we have determined, beyond a shadow of a doubt, that the metal wheels are the best wheels for running bandsaw blades. We've experimented. We've got a test machine that we can put blades on and just run them and see how long they'll run. And we have a lot of documentation about how long blades will run, different manufacturers' blades, and things that make a blade run longer. And what's so special about these wheels, they're not the cheapest way at all. They're more expensive. It takes us more time to put these on, but we just came to realize they were so much better that that's what we decided to go with. But we take these wheels and we actually grind these wheels. We put them on the shaft that's going on the sawmill, and then we put them on a machine that we actually built, and we grind a crown into this. That makes it running on this shaft with that bearing. It's a matched set, and we turn that wheel. It is turning, and it grinds it perfectly true. We want to be within 2 or 3 thousandths. We have found over the years, just experimenting and talking to customers, that if the wheels are 15 thousandths out or more, which is not very much, that they will break blades. We used to talk about those sawmills being blade eaters, but they vibrate so much, and what happens, this thing is just moving up and down and up and down. It looks like the blade to be 1/8 of an inch or 3/16 of an inch thick when it's less than a 1/16 in actuality. And so that comes from vibration, and vibration is the enemy. The more true these are, the more better life you get out of that blade. And we're all about blade life. We like to get blade life, accurate cutting and long life out of the blade. So we do match pair here. We do the same thing. This has a bearing, a sealed bearing inside it on the outer side. On the drive side, we build a drive bearing assembly. I'll show you some of that a little bit later. It has a taper bushing in it, and we match that as well. So both sides is matched. And what happens if you don't match these and grind them true, some companies use belt sheaves or belt pulleys, a lot of time we call them, and those are clamped in a vise a lot of times in 3 places, and actually pressure is expanded to hold that while they cut that groove down in the center of this wheel. And we have found that those can be out as much as the 15 thousandths in 3 spots. It actually expands this, and then once they release it, it contracts a little bit. We've also found that if we're not true and perfect round, and if these wheels are not exactly the same size, and if they're a little bit out of round, what'll happen is you'll get the mill, it'll run smooth, and then as they get out of round, they'll be going together. If I can run my fingers together at the same time, they'll be going together like this, and then one will slowly get ahead of the other. And you'll see it go through a cycle where it'll get vibrating, and then it'll smooth out. It'll get to vibrating more, and then it'll smooth out. That's because one of these wheels is a little bit different. It may be because of the belt or the urethane or whatever. And that causes a lot of vibration in here. And that is one big culprit to the breaking of bandsaw blades. So that is why we do that. You know, different people say different things about metal wheels and all kind of different things, but we know for a fact that they're the best way to go. They're more expensive, but we still do it, and that is why we do it. And it is absolutely the best way to run. I'll look at the band roller guides here. The roller guides, we use a roller guide, not a clamp type system, not a backup bearing or backup rub. Anything that rubs on the back of a bandsaw blade will create friction. And because these blades are really made of a spring steel with carbon in them, the way they're treated, they're heated and tempered at factories. Same thing happens to those teeth, and you can make them harder or softer based on putting in heat. Well, friction puts in heat, and if you ever have a lot of cracks in the back of your blade, that is coming from something rubbing the back of that blade. It's not a manufacturer's defect necessarily. It could be, but oftentimes we find that sandwich guides are a bad backup roller, and people who have other mills is what's causing that. With the roller guide, we do have a flange here. You do want to be able to, if you hit something very hard, to catch that, but we're not rubbing it all the time. One thing that's important when you set this blade up, and we have other videos that show some of this, is that it's running about 1/8 of an inch off of that flange. So when we're not in the cut, we're not touching that, and we're not causing friction on the back of that blade. So if you are running your flange or bearing right up against that all the time, you might consider giving it a little bit of a gap there, 1/8 of an inch. Then when you run into the log, sawing through the log, that blade can be pushed back. There is some flex in pushing it back. It can come back and just kiss that flange, is what we say. Just touch off on it. And we have a little video on how to adjust your roller guides as well. Something else that we have here that we did several years ago that we like is our drip system. And it's really a wiper system and not a drip system. We come out, run through a little filter there just so we keep everything good and clean. And we drip into a felt wick. And it actually touches the blade just below the gullet and wipes on our solvent onto the blade. And I do a little video also about different types of solvent. There's a lot of them out there. If you're running water with dishwashing liquid, you're in hardwood, sometimes you can do that. But overall, we just use a diesel fuel, and because of the felt wick wiper, we get a lot more life out of the diesel fuel, and we're putting a lot less on. That's why it lasts longer. And we're keeping it clean by wiping it on. If you have just a drip system, the set in these teeth running at the rates of speed that they go, anywhere from 4,000 to 5,000 feet per minute, they're causing a wind in there. And we also have a little bit of a breeze this morning that affects that. And if you're dripping, even if you're right above it, sometimes it sucks it off the back or blows it off the front. The felt wick wiper, it touches that blade and keeps it clean. What happens if you don't do that, you get buildup here on the wheel, which can cause a problem. It changes that crown, and but even more so, it builds up on the bandsaw blade. And we've seen, we sharpen blades for people. They ship them back to us and we sharpen them, and we have to clean that off sometimes. And we've seen it where the blade is actually twice as thick than it should be, and because of that buildup. And when it gets like that, you can't control it with the roller guides. The set is what clears the blade, the set in the teeth. And if that is building up on it, and generally it'll be built up on the inside because it's packing to that wheel. Sometimes it builds up on the outside as well. Then it begins rubbing, and it just can't clear itself through the cut. You've got to keep that off. One other thing to know about band wheels, I'll go right back to since I'm still standing here, is there is a little crown in these band wheels, a little curvature on the face right here of the band wheel, and that causes the wheel to track, and that's very important. And steel wheels have long life; they'll last for years. And just do you a great job, and another reason we like those. Okay, on the back side of the idle wheel where I was just standing, I want to show you our tensioning device, and it's basically a hinge system, and there's a pin right here, and this hinges out and in. We put this handle right here. It's got a slot and a pin that drives this, and we take that and we'll just turn it and back it out or screw it in. It's real easy, real simple way to do this. Something that makes ours different than a lot of people's is that we tighten against a spring in here. It's an 850-pound spring, figuring the pivot points and everything. What we end up doing is tensioning our blade up somewhere between 15 to 18,000 pounds, tensile pounds. But we're tightening against this spring. What the spring does for us is we compress it, and we just compress it to a certain spot every time. We have a mark right here. This comes out in the center of this milled out piece, machine part, and when we get it there, we know that we're at the proper tension. It doesn't matter as long as your blade is within an acceptable range, and we have probably close to 2-inch adjustment on a blade. You shouldn't need quite that much, but it doesn't matter that there's a little variation, and there are just a little variation in all blades if you cut them so that they can be sharpened continually. But when we tighten up and we compress against the spring, and that lets all that work out. I'll say this, we talked about longer life a minute ago. The less tension you can run on a blade, to some degree at least, you get longer blade life. If you really tighten up on the blade, sometimes you can make that blade run a lot faster for a short amount of time. But it causes, we talk about in other videos, anti-clastic curvature. It makes that blade begin to curve faster because you're tightening it real tight on wheels. And that's not just crowned wheels. That's any time you're going around a circle of a wheel. Sometimes people say, well, that's because of the crown or because it's this or that metal wheel or whatever. That's just about going around the wheel. But the tighter you put that, the more you tend to speed up that anti-clastic curvature, which causes you trouble with dipping and diving. But also, you're just literally putting more stress on that blade by jacking it out tighter. So if you need to go faster, you can work with and try to find that happy medium. But to just get on here and say, well, I'll just tighten that thing up until it's totally tight, probably is not the best answer. If you can run it a little bit on the lower side, then you probably find yourself getting a lot more life. If you're just sawing a few logs in a day, not trying to be commercial, so to speak, or having to get a lot done and you're just slowly cutting some along, then I would suggest running it with a little less tension. Now, tracking it and all those things come into play as well about how you tension it. But if you can run with lower tension, then you find that your blade will last a little bit longer. We have that pivot here that comes out when you loosen up on the wheel. This hinge should go in, and what we like to do is we'll just pull right here. We'll pull that handle up and get a little leverage and pull right there to make sure it goes back in. Sometimes they're a little bit tight and you just push it right back in real easily. One thing about tightening against the spring also, different people have different methods. Some use hydraulic tensioning, some use just tightening a bolt. We've got an Acme threaded bolt here, and they just tighten the bolt to a certain spot. Well, number one, you don't get the advantage of that spring giving you a little bit of extra give in there when sawdust goes between the blade, we talked about a little bit ago, or sometimes when a little piece of bark goes between there. Now you've got a chunk going between there, and that spring gives you a little bit of cushion. It helps you out. It gives you better blade life. The other problem or thing that you need to know is when you tension, if you're just using a bolt to jack it out, bolts, I've seen them just kind of get stiff up in the hole up in there where you're just turning metal against metal. But they get little hangs, things can happen, a little rust, and some people are using just a torque wrench. Well, it can torque out because of galding or tightness, as opposed to getting to a specific point every time. Same thing can apply as well if you're just using a gauge, a pressure gauge. you may reach a pressure, but it's because of tightness or binding. We're outside a lot of time with these mills, most of the time. Rust factor comes into play, that galding, the threads get worn a little bit. A lot of things come into play with that. But when you're compressing and coming to a mark, that mark always stays the same. If it won't get to the mark, you hadn't got there. You know that by what you're looking at. We do use hydraulic on our AC36 mills, but that is something that we're aware of. We're still coming to the mark, whereas other people are just using a gauge, and that can fool you sometimes. So that's the one thing I wanted to mention there. I'll go ahead while I'm on this side and mention the roller guides. We talked about them a little bit, but we have an adjustable roller guide on the operator side. We set this up to try to make it the easiest and fastest for the manual type mill, but this is on the operator side, and so the adjustable guide is over here, and it can be moved in and out according to what you want, according to what your need is. If you're sawing something that is perfectly uniform, you can set it one time and leave it. If you're sawing logs that are different sizes, what I kind of like to do is just make this thing, I'll pull it out about 3/4 of the way, and I'll tighten it up right there, and that will work with nearly all of my logs. Once in a while I get a much bigger log and I'll have to adjust it out a little bit more. But overall, I'm not moving this in and out all the time. And the way this tightens up in the corner of this tubing, when we tighten it up, it puts it back in the same place and it's good and tight. One thing I didn't mention on the other side, I don't know if you can see it at this point, but we have a sawdust blocker here, we call it. You can see where sawdust is actually built up on that. But that keeps some of that sawdust from going in there against that wheel as well. So on the roller guide on the other side. Another thing I like to talk about on our MP32 mill is we mentioned heavy duty. This is a stout 4-post mill. It's got a heavy tubing here, and 2 over here. It takes the shake out. Some mills they're cantilevered or built in different ways, but this mill is stout and steady. I'm lifting up and down on this, and you don't get a flop. And that's really important. When you're sawing through the cut, you don't want it to be able to float up and down. And I've seen mills that you could literally just grab and just wiggle them all around. And this mill is good and steady, heavy duty. It holds itself down. This frame that holds the band wheel is 3x6 tubing. Actually it's the same tubing that we use on this head that we use on our AC36 mill, our big heavy duty commercial mill. As a matter of fact, we use a lot of parts. The roller guides are the same, this tubing's the same, the frame is the same type tubing. It's just a heavy duty mill. I don't know of one that is stronger built out there. As I walk around, I'll show you, this is a manual mill, we call it, but on this one we do have features that we add. We have a 12-volt system that raises the head up and down. We have a brake right here. It's just real simple stuff that we like to make things as simple as it can be. Something that, like I said, these hardly ever have a problem. But if you had a little problem with a whatever on here, sprocket, chain, it's 40 roller chain. It's simple stuff that generally you can buy you know, at an auto parts or at a hardware near your home, and you don't have to buy everything back through us. But we have a brake, and then we have just a lever here. This will raise it up, and we can go up to 30 inches. And this is a 32-inch mill. We can go up to 30 inches. You got to cut into the log anyway, and you can go down. The real advantage of this is the going up. The going down, if you don't have this, it will go down easily by hand. And if this belt is off and you don't have the 12-volt system, you can just pull the lever and it'll fall down on its own. But then you have to crank it up. And so the 12-volt advantage is really going up. It makes it really nice. Then on the forward and reverse, we can put just the head up and down, and you can push it through. In this case, we have the power head forward and reverse. We can slow this thing down, turn it off actually right there, or slow it down to just a real slow crawl, or go a little faster. And so I'm just holding the button, just pressing the button here. Or I can press the button and it comes back. So I don't have to strain myself. I know as I get older, I don't need as near the strain that I've had in the past. So that is a handy feature that a lot of people like, and they use that. Our belt engaging, to engage the blade, we tighten up a belt. We use what's called a slip belt. We've done this for many years, and we've stayed with it. Some people ask about a clutch and different things. Those are expensive. When we have tried that in the past, there's always been aggravations and problems with it. And if it's an aggravation to our customers, it's an aggravation to us too. This has just been proven where we engage, it lifts an arm on the other side. Again, simple. We're after simplicity, something that makes sawing simple so we can keep sawing and not be dealing with clutches that may not hold as tight as they should, that springs come out of, that locks don't lock in like they should. There's a lot of things that have happened that we've dealt with over the years in dealing with clutches that just doesn't work out very well. Or either you have to get into tremendously expensive things that are just don't fit what we're trying to do right here with this mill. We use Kohler engines. We've been using them for a lot of years. They have good warranties. They're just good, solid running engines. We enjoy dealing with Kohler, and they're just good, solid engines. We have several sizes there that will work and do what we need to do with the mill. Okay, we're here on the drive side of the sawmill, and we have a cover here for the belt that I mentioned from the other side. Safety cover, and of course the guard for the drive wheel, we say over here. The belt comes down to a pulley, and we go through this drive bearing assembly. We put it in the machine shop, and we machine this out, and we use tapered roller bearings, just like what you use in your axles on a truck, on a big truck. And so we have 2 1/8 inch size shaft on this side, and 1 7/8 on this side, and that's just in how we make that. But it is long lasting, and the reason we went to this many years ago, in the first year or two, the popular thing, and many sawmills still do this, I think, but they use pillar block bearings. They'll have one here and one here, and it doesn't matter if you're going with a 2 or a 2 1/2 inch bearing. There's such pressures in this overhung load till it'll cause this bearing most often to go out, number one, but number two is it can actually, they're cast, those are cast, whereas this is solid steel. Sometime it'll break those housings. There's so much pressure, especially if somebody decides I'm going to tension this thing on up and speed it up, as people have done from time to time. It can cause, if you had pillar blocks in there, to break. But this is solid steel housing. We set it up in such a way, and we talk about this on other videos, so that we can adjust these wheels. There's actually an adjuster. This is something we've added in recent months here, so that we can get this tilt of this wheel just like we want it. And we found just 1/16 to 1/8 tilted out at the top is ideal to help with the roller guides, to help this thing run straight through there. Just all the dynamics of the anti-elastic curvature and as a blade dulls, a lot of things. We've just learned that is what works the best, and we've done all kind of things, and that's what we found. But this is something we've added, again, even to our MP32 mill, the hobby mill that sometimes people use commercially, but to our less expensive mill, we're still trying to add value in these all the time, and so that's something else that is very helpful. We have locks on all 4 wheels. It's a bolt that comes in against the V-track roller that runs down the track here, but that can be locked at any time, no matter where you are. Safety is always important. Okay, we're at the bed, the log bed. We have stainless steel caps on the log bed, something that customers, again, kind of wanted through the years, and so we've added those. But the main part of the bed is how you roll the log and clamping the log. This is what we call our squaring arms, and we roll against these. They're tied together down underneath, so if I move one, the other one moves. We have an arm down here, so we can again push it with my leg instead of trying to do everything by hand, and you can grab it here as well. Sometimes if a log's up against this, it's harder to move, and so you can bump it with your foot, and sometimes that helps out. But this we call our squaring arm, and it is 90 degrees to the bed. We set up a couple of pieces here and put a square against this, and it's adjustable so that we're at 90 degrees to the bed, so that when I clamp this log up the first time and I cut it, if I want to turn the log and put that flat against here, I can do that and cut it. I can also, and what I like to do on this manual mill is I'll cut the top and I'll flip that all the way down, and then we'll push this down out of the way so that I saw above it, and then I'll cut that again, and now I've got flat on two sides. I'll lift this back up, roll that up flat against it so that I get in. I've got clean on this side and the back side now. It lets me get into the clean wood a little faster. On our hydraulic mills, we turn the opposite way, and that lets us get into clean wood right after the first cut. But you only have one more cut doing it this way. Or you can leave it round and go up against it with it round and do that if you'd like to. Our clamping system is a cam type system. This is the cam, and this moves back and forth. So we put the log, we just push it up against it, and then when I press that, it closes this in. This moves in. So that's how we clamp it. We like to have two clamps. I know some people only have one, but we put two clamps. That's standard on our mills. There are times you need two clamps. Jacks. We used to have just legs that slid up and down. This is something we've added recently. We have jacks on the end of the mill, in the middle of the mill, and then back on the other end. Very easy to set up. We use these jacks on the front to jack it up and put it on the ball of your truck to pull it down the road. But you can jack these up, kind of set the ends up, and then jack the middle down tight, and it's just a good way to set up a mill. It just works very well. And then we have the log winch for loading the log. Now I'll tell you up front, if you have a front end loader or a skid steer or something, that's just the fastest and easiest way to load a log. But sometimes you don't, and you still want to be able to saw. So we have a 12-volt winch that we'll winch out, and we'll demonstrate this going up. It's not as fast as I would like, but it'll load the biggest log that you can put on here without any problem. So we'll demonstrate that here in just a moment as well. And we wanted to show the log loader for the MP32. Now we actually did a demo the other day and was showing that, and the customer who was going to get the mill showed up, and so we stopped just short of loading the log and let him take his meal. And so we're doing this, and you'll see there's a different meal. I'm probably in different clothes. But we wanted to show this log being pulled up there, and so I'll demonstrate that at this time. Of course, the best way is if you've got a lift of some type, you can load these right up there on there. But we do provide these ramps. This is a timberjack cant hook, and I'll jack this log up, and I'll go and pull the cable around and hook it back to itself or back to the mount up here, and then we'll load this log up. So I've got this where it'll free spool out. I want to be fairly near the center of the log, and like I said, I'm gonna go over here this way. And since I've got the winch on free spool, I can spool it out here and pull the length as I need it. And it does take a little more time, but if you don't have a forklift, it is a handy way to do this. And then I'll just release the timber jack, and we will tighten it up. since I've got kind of a fairly short log, I'm gonna release that. And as I said, it takes a little more time, but we have these flippers that come up, and I'm gonna slide that back down a little bit. The log is a little bit larger on the far end there, and so it should catch up if we can get it fairly even. But sometimes you have to. If you have a heifer, then this becomes a whole lot easier and faster to do. But you can see it winches it right up. It's been several years ago, but we can actually load a 36-inch log. This is only a 32-inch machine, but you can see it does a good job. It gets it up where you can get it, where you can work with it real easy. So that's the way that our winch system works. Again, not for everybody. If you have a forklift, then that's the easier way to do. But if you don't and you still want a sawmill, this is a way to do this. We're about to saw the log now, and I just want to show you how easy these ramps just fit right in the slot. And there's actually another one right here if you had real short logs that you could use as well. So I'll move these out of the way, and then we'll start sawing. Okay, so we got the log loaded, so we're about to saw it now. Now on this mill, we have 3 squaring arms. I don't know if you can see them all 3 on the back. That is not standard. Standard is 2. But if you want an extra one, you can saw 4-foot logs, and you have a better way to clamp it. It actually has 3 clamps as well. We put 2 as standard. So if you want an extra or you have special needs, that's one thing good about us here at Cook Saw. We try to help you with little bit custom changes if we need to, if it's something that you need and want to work that out. We have a lever down here on the bottom. I like to use my foot down here to push it, and it brings my squaring arms up and down. I can also reach over, or if I'm on the other side, I can do it from here as well. So I just put these squaring arms at about half the height of the log. That way I'm sure I won't be hitting it. Our clamps come over against the log and just press down, and we have 2 of them. A lot of times, as you saw, you'll learn little tricks and different things. You don't necessarily have to put 2 of them on the log. 1 quite often is enough, but anyway, that's how you clamp the log up. It's pretty simple. And then I'll just saw. Okay, we just demonstrated the mill and wanted to show you that it'll square up a log. I like to cut a real short or thin piece like this. You can see that thing is the same all the way down. Probably could even cut it a little bit thinner, but it just cuts a perfectly accurate cut. That's less than 1/8 of an inch right at it. And that's something that I just do to show how accurate these mills are. We squared up this cant, not a huge log, but we're at about 8 inches square there. It'll just do a really good job. These mills are just dependable, they're accurate. Setup has to be right, but it's not that tedious. We're out here in a pasture. We pull this out, jacked it up, got it set up in 15 minutes probably, and you can just be set up and ready to go.